see what else needs to happen. The HNO3s, that's the first product, I believe we have taken care of. I see it on the product side in that second elementary reaction, and we have the desired amount. We have 2 units by cutting the half from up above. We have the product NO, which appears in a unique position in number 3. No, it's not unique. I see it in equation 1 and equation 3. Alrighty. Now equation 1 we adjusted. Remember, when I stare at the original equation, there were 2 units that might appear that we wanted to cancel those out, and they would have, except we had to adjust that first equation. So leave the third one alone. Let's just rewrite it as it is. Leave it alone. N2 plus O2 gives us 2 NOs. And I didn't do a darn thing, so I'm just rewriting the delta H, positive 183 kJs. If we add these equations together, simplifying anything from the opposite sides of the arrows, cancel them out just as you would in algebra. Here's what I'm finding. I have on the left side of the arrow, let's see, nitrogens are combining. Well, interestingly enough, this number 3, I think I made a mistake. But examining is always the secret to figure out if we've done this correctly. What I noticed is there's no nitrogen in the target equation. You probably noticed that right away. The nitrogens have to disappear. Right now, my equations are combining them. That doesn't make sense. I think I need to go back to the drawing board and flip the direction of the third. And if I flip it, I got to change the sign. Back the bus up. Let's rewrite the third equation in the opposite direction. I bet magic happens. 2 NOs yields N2 plus O2. Now I'm seeing it. All right, new color. Here's what we've got going. N2s now cancel. I have 1 molecule of N2 on the left in equation 2, 1 on the right in equation 3. They cancel. What else might cancel or simplify? I have, how about here? 2 molecules of NO on the left in equation 3, 3 molecules of NO on the right in equation 1. That can be simplified. And that's the whole reason I knew to flip this one. 2 units of NO leave me a net remainder of 1 NO in that top equation. Here's what else we see. On the left side of the arrow in equation 2, there's 5 halves of oxygen. On the right side is some oxygen in both equation 1 and 3. 3 halves and 1 whole more is the same as 5 halves. Think of this as 2 over 2, and you can simply add 3 plus 2 to make 5 halves. That's going to simplify, and the oxygens are all gone. 5 halves combined on the right can simplify with the 5 halves written in equation 2. And I think we've got there. I had one little flip in equation 3 that I had to repair, but here's what's left over. Equation 1 has 3 units of NO2. That's the first target reactant. I see in equation 2 a reactant, and that's the water molecule. That's cool, because there it is. It's in our target. Those are the only 2 reactants left over, and they match the target. Let's look to the right side of the arrows. I have 1 molecule of NO that did not cancel out, and that's in our target, and 2 molecules of HNO3. This indeed matches the target equation. The only thing left to do is to sum the 3 delta H's to get the new equation. Add together what we've calculated. So positive 174, let me show the calculator, plus negative 128, plus a negative 183. And the heat of our reaction for the target equation is negative 137 kilojoules of heat. Hess's law, little puzzles. What can I do with these elementary reactions so that when I combine them back and simplify, I've built the target? I like them as little mental practices, little puzzles. Obviously, I got to keep trying if something isn't working. Pause the video, take a look at this next practice, and when ready, play it.